Hello guys, in this video I will try to give an overview of the bachelor thesis topic titled Database Clustering for Retrospective Sensing in LoRa Networks. So I'll start with giving you an overview of the concept of retrospective sensing, which is an architecture that we are doing in collaboration with the University of Ulm. So this project is actually a joint collaboration between ourselves and the University of Ulm. So the concept of retrospective sensing, retrospective means going back to the future, and any IoT system would have a sensing layer, but then we have a vast or a huge amount of data that will be need to be organized over the cloud. The concept of retrospective sensing is that in a lot of cases you're trying to predict some event, and as long as the event doesn't occur, so let's say you wanna monitor pollution in the air. So as long as there is no problem, then you really don't need to measure too much data. So you would send some snapshots or some averages or some representative data. And this is what you send to the cloud. And then you need to organize them in an architectural way. And this is what is done in the retrospective event processing plane. So you organize them and you keep on monitoring this data, or this aggregated data or representative data. But once you find that an event could have happened, this is where the retrospective sensing concept comes, is that you would want to go back to the future, back to the past, I'm sorry, and ask the sensing layer, which has the stored fine-grained data, to resend what you have not sent before. So let's take an example. As I said, you are measuring the air quality, for example, and then you send data once every a minute or so. But your sensing is done on a second-by-second basis. But because you don't want to drain the battery of the device, because you don't want to overload the network with too much data, then you just send at the scale of once per minute. Now, at the retrospective sensing event processing plane, it processes these samples and then it detects that maybe an event of high pollution or whatever event you're looking for has occurred. And then you have to ask the sensing layer, I need more data. So you go and do the retrospective sensing, not necessarily from the whole network, but only for the area where you would need the fine details of the data that you would like to process. So this is the retrospective sensing concept. Now the group of Ulm have come up with a graph-based storage system where they store the data in a distributed fashion such that it is easy to make queries to check for particular events, and it is its responsibility to trigger the retrospective sensing call to the sensing layer. So let's now look at the second keyword in our project, which is database clustering. So database clustering, or the term clustering as referred to in the previous slide, is that we would try to represent some representative data that represents the full data to conserve our energy. We can do this in time, as the example I have given, that you send once every minute, and even if you're sensing every second, you just use one every minute to economize on your energy consumption. Another way to economize is to have a clustering, which means that, for example, sensors 10, 11, and 12, instead of sending data from all of them, you select a candidate that will represent the others as long as there is a correlation between them. Usually, before database clustering was usually based on distance, which means that sensors are close to each other, have a high likelihood that their data will be correlated, and therefore you can have one sensor represent the data collected from the others. But a new trend is that practically actually the location is not necessarily the representation of how close the data are. Because if you look at the figure on the right, which is like a heat map for the temperature, you can see that all the sensors that are close to the window, such as sensor 11 and sensor 1, even though they are not close in distance, but the readings would be highly correlated because they're close to the window, and therefore their temperature will be similar. So the idea of database clustering is that you group sensors, or identify sensors with high correlation, not based on their location, but based on the data that has been measured. So let me move on to explain our project. So in this project, we have already, in previous work in a master thesis, we have done a database clustering scheme using machine learning. And the idea of the database clustering is that we have built a graph. The graph, the links between any two sensors means that they're strongly correlated. And essentially, in order to have a cluster, you would like to have all the sensors within the same cluster to have a strong correlation between them, because we will be using one of them to represent the data within this cluster. So if you look at the graph on the right, you will find that you have two graphs. One is connected and the other one are disconnected. The connected graph represents the relation, and you can see that we have divided these into three clusters. You look at these three subgraphs, you will find that all of them are fully connected, which means that all the members of the cluster will have the strong correlation between them, such that any sensor within a cluster can represent the remaining data. So the objective of the project is to take it a further step and try to implement this in conjunction with the bigger picture. So we would like to implement this database clustering scheme in Python, using the machine learning technique that will be explained during the project. And then the group in Ulm, they have a simulation model to generate sensor traffic. We would like to integrate this simulation model with the implemented data clustering scheme. And then once we have this, we would like also to create some integration or some API to send the cluster readings, which is one packet per cluster, to the retrospective sensing platform of the University of Ulm, such that we have like a full-fledged or a full scale of the proposed system. So the tools that we will be using in this project will be Python and machine learning, where we will be focusing on clustering. So this summarizes the this project. I hope it was clear.